Hi folks! The functionality in the modern vehicle are based on software, hardware and mechanics interacting. To synchronize this, it is necessary for your development teams to work together right from the start. With SPICE for mechanical domain, you develop your mechanical systems in coordination with the software parts. Watch this tutorial video to learn how SPICE for mechanical engineering works. I'm Andrei Donchuk, expert in the area of mechanical development at Kugler Mark. I am the deputy lead of the Intex working group which developed the standard SPICE for mechanical engineering. I hope you can profit from watching this video. Since there are mutual influences between the mechanical, software and electric and electronic design aspects, to build a high-quality mechatronic product, it is also required that all disciplines work well together. Automotive SPICE was developed for system and software development. There is hardware SPICE to support hardware development and SPICE for mechanical engineering as a reference model for mechanical development. Modern product engineering utilize software development tools in nearly all phases of the development lifecycle. This has caused an increase in the number of intermediate and final work products which teams create and use to design and analyze their product. Consequently, support and demand for processes such as configuration management and change request management will need to be even stronger. Furthermore, higher computing performance and new production methods have both significantly changed the mechanical systems. Shapes with considerably higher complexity can be developed and produced. The production lines are developed in parallel with the product. This dependency leads to a very high costs and effort to be spent when changes are introduced after the design freeze, in contrast to software. Therefore, front-loading and high process quality in the engineering processes are indispensable for the mechanical aspects of a product design. Okay, in brief, SPICE for mechanical engineering defines best practices for automotive mechanical development to achieve the required product quality. This video gives you a very condensed overview of the SPICE for mechanical engineering standard. Let's start with the formal structure of SPICE for mechanical engineering. The SPICE for mechanical engineering standard can be used as a plugin for Automotive SPICE. In doing so, the processes of Automotive SPICE are used for both system and software development. Additionally, for management and support processes, the SPICE for mechanical engineering processes address mechanical development. The standard consists of two process groups. First, mechanical system engineering, and second, mechanical component engineering. The mechanical systems engineering process group contains 4 processes, while the mechanical components engineering process group comprises 5 processes. A mechanical component is the lowest level of your assembly drawing. This could be a screw or a part which is developed by the supplier. In the second case, the supplied part is a mechanical component for you, but from the supplier's perspective, it is a mechanical system. In other words, mechanical components are all the parts that you do not need to refine further in the assembly drawings, so you can consider them as a black box. A mechanical system, in turn, consists of 2 or more mechanical components. Let's take a closer look at the processes that make up the standard. We don't need to look at all 9 processes individually. Many processes are similar at the system and component level. The only difference is the degree of detail. MCE.4 Mechanical System Requirements Analysis and MCE.1 Mechanical Component Requirements Analysis. The mechanical system or component requirement analysis processes documents a specification for a structured way of identification, analysis, and the documentation of the mechanical system or component requirements. In your project, you can combine the MSE1 and the MCE1 processes into one process. Nevertheless, it is important to define requirements for both the mechanical systems and the mechanical components. Based on the upper system requirements and upper system architectural design, the specific mechanical system or component requirements shall be specified and documented. The requirements answer to the questions what this mechanical system or component shall implement and not how to implement it. Examples of the mechanical system or component requirements are weight, speed, torque, and force. Structure, categorize and prioritize the mechanical system or component requirements to keep an overview and control over the requirements. Analyze the technical requirements with particular care. This is to ensure the quality of the product requirements or to find and correct any errors as early as possible. When analyzing the product requirements, involve the relevant development departments or engineering disciplines and consider both product-specific aspects and general quality criteria. Early involvement of the relevant development departments or disciplines, for example, V&V responsible, system and electronic developers, is crucial. A typical example of a mechanical system architectural design is the assembly model and the assembly drawing, including the description of the interfaces and the corresponding design constraints. Examples of the mechanical interfaces are design spaces, shafts, mounting geometries. Design constraints could be design guidelines, legal norms and regulations, or the defined costs of the mechanical system, which restrict you to choose a certain types of materials. In addition, you could have also a functional architecture and a mechanical system breakdown structure. Allocate the requirements to the corresponding elements to ensure that all requirements are considered in the mechanical system architectural design. Identify special characteristics of your mechanical system architectural design. The special characteristics are the riskiest elements of your architectural design and are typically identified within the FMEA method. Analyze static and dynamic behavior, for example, via axis deflection and modal analysis. Verify the mechanical system architectural design against the requirements defined in the MCE1 process. This ensures at an early point in time the designed mechanical system will meet its requirements. The typical verification methods are simulations, for example FEM, calculations, risk assessments, and of course design reviews. A typical example of a mechanical component design is a drawing of a single mechanical component, for example of a screw. The MCE.3 Mechanical System Integration and Integration Test and MCE.4 Test Against Mechanical Component Design processes specify a structured way how you can find failures where the built mechanical samples are not according to the defined design. You need an integration and test strategy, including a regression test strategy. The integration strategy shall document the assembly steps of a prototype and their sequence. This is similar with an assembly instruction for a model kit. Process parameters and the required environment shall be recorded while the integration is performed. Verify with a mechanical system integration test wherever the defined interfaces match. For example, do all the gears fit together, or can you switch them? A typical test against mechanical component design is performed in the sample shop where all the defined dimensions are measured. Define a test specification prior to the testing of the mechanical system or of the mechanical component. This is necessary to perform the testing in a structured way. A test specification contains, as example, a test design, test procedure with the test steps, test criteria for passed or failed. Test your mechanical system and mechanical components according to the test strategy and the test specifications. We come to the next process, MCE.4 Mechanical Component Sample Production. This process was defined to ensure a structured way of sample production. Please note, this process is only valid for you if you create or produce a mechanical component. If you assemble a mechanical system with already produced mechanical components, use the MCE.4 Mechanical System Integration and Integration Test process instead. The first outcome of this MCE.4 process is a mechanical component production strategy. It includes sample production methods, for example, casting or 3D printing, production flow, verification strategy, production documentation, measures reports, and so on. Agree the mechanical component production strategy with all affected parties, for example, with sample shop, development department, serial production, project management. Produce the component samples according to the strategy and record the production data. Now we are through with the processes for mechanic development. Remember the V shape with the left and the right side with which these processes are arranged. Each process on the right correlates with at least one of the elements on the left side. To demonstrate that your results on the right match the requirements or architecture on the left, Automotive SPICE uses traceability. This establishes a link between elements of different development outcomes, for example, between a requirement and the associated tests. On the right side, consistency checks are required. This built on traceability. SPICE for Mechanical Engineering defines traceability and consistency like Automotive SPICE. In addition, communicate on the left side of the V-model the agreed outcomes to all parties involved. For example, communication of the agreed requirements. On the right side of the V-model, the summary and the communication of the verification results are required. The process MCE.4 Mechanical Component Sample Production contains both requirements, as this process is partially on the left side of the V-model and partially on the right side of the V-model. If you are interested in process improvement in general or especially in SPICE topics, subscribe to this channel. You can download a more detailed white paper in the description below. Don't forget to share this video with your colleagues and give us a thumbs up. Finally, thanks for watching and good luck with your SPICE for Mechanical Engineering practice. See you soon again.